All right, straight up integrals. Antiderivative of all of these are all indefinite, so we'll definitely put a plus c, so that's no big deal. You'll see it on the multiple choice parts. You've got the antiderivative of this guy. We're going to add 1 degree, so make that 2. And then this guy would be 5 over 2. And then this would be plus 3x plus c. All right, number 14. Not much math to do, right? We're just adding an extra degree to each. This guy right here looks like we just got this guy in pieces, so the antiderivative of this guy is easy enough. That plus 1/2 x squared. Then this is x to the negative 1/2, so go ahead and add a degree. All right, and then what we would have to do is put a 2 there so it would cancel out. And then it would drop a degree, and then he'd go negative 1/2. So there he is, plus c. All right, I'll check these to make sure that they're all correct in case I make a dumb mistake here. This guy right here is just going to be pi x. And then this guy would be, you're going to raise him a degree. I like to raise it a degree first and then go ahead and divide by whatever that is. Okay. All right, this guy right here, we're going to actually go ahead and divide each one of those by x so that we get a 4x. But notice that I keep the integral because I'm not going to take the integral yet. Minus 5 plus 3x to the negative 1 dx equals, now we're going to have 2x squared minus 5x there. And then this guy would be adding a degree, so this would be the same as, if I add a degree, I'd get 0, so that's the ln. So that is the plus 3, the ln of x plus c. And I'll put those absolute values in there just in case. Okay, that's technically correct. So this is our final answer right there. All right, this guy right here, we're going to go ahead and add a degree, which would be 4 over 4, which would give us positive 1/4. And then, because there's no number there, we would have to have a 4 right there. And we'll just make sure that he drops, yep. All right. All right, this one looks like, oh man, I don't have those around me. I wonder where they are. This guy right here is actually, okay, I had to go look them up. This is actually sine. So that is sine, and we don't have our a and our u is actually just as it is. So we got the sine of x inverse plus c. It's the same for number 20. I know I'm skipping here, but that's actually the tangent, inverse tangent. Okay, so that's cool. As long as you recognize the pattern. This guy right here, this x is kind of messing things up. So what we got to do here is we are going to make this a u of x squared minus 1. So that du is 2x. Then we're going to make that 1/2 du equals x. And that would be an x dx. And that's exactly what we got. So now we have 1/2 of the antiderivative of 1 over u, which is that guy right there. All right, so now let's just go ahead. I'm sorry I'm writing this small here, but it's 1/2. The antiderivative of this guy is actually ln. And our u is actually x squared minus 1. Put that guy back in. And that's it. It's that, I wouldn't say that's that simple, but that is the guy because he is a special one. So remember the antiderivative is ln. All right, now we got some antiderivatives that, yeah, you could use your calculator to check them, okay? But make sure you know how to do this by hand. You do need to show your work for a couple of these. We're going to go ahead and take the antiderivative here, so we get x. Then this would be minus x squared, and we're going to evaluate that at 2 and 0. So the first part is 2 minus 4 minus 0 minus 0 would just be 0. So I like to put big brackets for that to let me remember that this second piece is the whole thing is 0. And that actually equals negative 2. Okay, so negative 2 minus 0 is just negative 2. Okay, now this guy right here, before we take the antiderivative, we're going to distribute this. So x to the 1/2 times x, you would add those. That would be x to the 3/2, which is a lot easier to take the antiderivative, minus x to the 1/2. Okay, so now we take the antiderivative here, and that would add 1, which would give us 5/2, which means we have to multiply it by 2/5, minus, then we would have to add a degree, so that would be 3/2, and then we'd have to multiply by 2/3. We're going to evaluate that at 4 and 1. Okay, so hopefully this is... I don't like all these fractions, but I am going to actually be very careful with this because, let's see, 4 here first. Square root of 4 is 2. 2 to the 5th power is 32. 32 times 2 is 64. That is 64 minus 5. Okay, minus 4, square root of that is 2. 2 to the 3rd is 8. 16/3. 16/3? Really? Ugh. Let me try that again just to be careful. 4 square root 8. 8. Yeah, that's 16/3. All right, minus, and then we got 1 goes in here. That's going to be 1. That's 2/5. Minus 1 minus 2/3. Ugh. Okay. Well, magic calculator. Let's see if you can do this for me here. Minus 16/3. Hit enter. 112/15. Oh, you can't see it. 112/15. I guess that's what this is, which makes sense. And then this guy, what is 2/5? I just don't trust myself this early. 2/5 minus 2/3. I'm sure I could probably do that. Okay, so now I have to minus that. So this guy minus this guy. 1/16/15. All right, that's pretty cool. All right, what is that as a decimal? Let's see. That's 7.3. Okay, now let's actually take the antiderivative. I am just wondering. Let's go from 1 to 4. Let's see how close this is. And we're going to have x to the 1/2 times x minus 1. Close that parenthesis up, close that up, make that x, and let's see how long it takes to do that. Oh, we did it. So 1/16/15 is exactly correct. We did it instantly. That's pretty impressive. Yep, they match. So this means that we are 100% correct. Okay, so all right, I never liked having that dx in the numerator like that. So let's just make this a 1/x² dx, just like that. And what we could do is, let's see, 1/x². We're going to write that again as x to the -2. All right, so now we're going to add 1. We're going to get x to the -1, and then we will have to divide by -1/1. So we're going to evaluate it at these two locations. That's easy enough. What does that look like? It looks like -1/x evaluated at 4 and -1. I think that just looks better actually to do rather than keep it like this. So we're going to go -1/4 minus a -1/1. Ooh boy. Okay, so careful. -1/4. That is a okay, so that's a positive. So -1 is a -4/5. -4/5. Okay, so I'm going to do this again. Not there. I'll go here. Alpha. Nope, math. Okay, we are going from -1 to 4, and we want 1 divided by x to the second power. Okay, I'm actually going to put this in parentheses. I'm a little nervous. There. All right, taking a little time there. Doesn't like that one. Oh, look at it working. Tolerance not met. Ooh, it does not like that one at all. Let's check that again. Let's see. -4 to -1 to 4. 1 over x squared. Okay, well, see, that is the problem with these. It just didn't like having to calculate the antiderivative to that. So, yeah, we will. I'm gonna go with it. It just feels right. This one right here looks like that is the inverse tangent. So it is inverse tangent, evaluated at 1 and 0. Okay, so the inverse tangent of 1 minus the inverse tangent of 0. Okay, so what is the inverse tangent of 1? The inverse tangent of 1 is actually, where does tangent equal 1? Tangent equals 1 at the degree. So remember, inverses give you degrees, okay? And if it was a plain old tangent, you would want that to be a degree, and then you get the value. This is the value, get the degree. So he is at 1 at pi over 4. And the tangent of 0, he actually equals 0 when sine is 0. So sine is 0 at 0. So that is just pi over 4. Okay, so that's kind of cool. That right there is pi over 4. And we recognize that that guy is this one right there. It's the same thing. Just addition is commutative like that. Okay, so now let's take the antiderivative of this guy. Antiderivative of the, what are we at? 12 minutes? That's okay. All right, we went through a lot of these. This is going to be the brunt of your test, by the way. You know, there's going to be one trapezoidal and one left and right. And I think, yeah, this is going to be a slimmed down test. I might even think there's maybe 15 questions on it total. All right, so what do we got? We got antiderivative of this guy is cosine, okay, of 2. I'm sorry, of 2 cosine x. And let's just verify that the derivative of this is this, and that is incorrect. We need this to be a negative, okay? Because the derivative of cosine is a negative sign, and we need to get rid of it. So if we were to use a chain rule there, we would find that it would equal that. We're going to go from pi over 3 to 0. So negative cosine of pi over 3 minus -2 cosine of 0. Okay, what do we get? Cosine of pi over 3 is actually 1/2. So that would be -2 times 1/2 is -1. Now there's going to be a plus 2 times the cosine of 0. The cosine of 0 is 1, so that would be plus 2. So our answer is actually an area of 1. Okay. All right. This guy, you're going to actually split this up over underneath each one of those. So we're going to rewrite this guy. Going from 1 to 4, but this is going to be a 3x. I'm going to write it out just because this is a review. Oh, that's nice. Look at that. Okay. Okay, cool. Cancel out there, right? Cancel out there. And then that is what he is. I feel like we just did him. He's right over there, but unfortunately we are going from different places, but it's the same antiderivative, so we could use him. So we got the antiderivative of 3, which is 3x. This guy is going to be 1/2. So let's write that as 1/2. We're going to add x to the 1/2, but we're going to actually, I'm sorry, 3/2. Then this would be 2/3 minus the antiderivative of this guy we said was him. So we've got plus 1/x. And we're going from 4 to 1. Okay, this is kind of a beast here. All right, so we've got the 4 part right here minus the 1 part. Okay, so 4 part is 12 plus 4 square root is 2, 8. That's 16/3 again. And then there'd be 1/4. Then a 1, we got 3 plus 2/3 plus 1. Okay, well, oh man, I do not trust myself. Plus 16/3 plus 1/4. Oh, you know what? I know why it turned it into decimals. I shouldn't have done that. I should have went like this. If I do this, I believe it keeps it in fractions. It does. Got 211/12 minus, it's going to be 4 plus 1/3, 2/3. 4 2/3 equals 14/3. So minus 14/3 minus 14/3. We got 155/12. Okay, and we could go ahead and type this in, but I do feel like that's going to give us a problem there. So I don't know. Maybe we can here. Let's see. Let's simplify it. I know this is the last one. We're pushing the 17-minute mark. This is a long one, but again, this is a big part of the test. This is just to verify whether or not, and this is actually can kind of show you how you can check your answers. Okay, we're going to go from 1 to 4, and this guy simplified is going to be 3, then plus, and we said this is the square root of x. Okay, and then this is going to be minus 1/x². Well, I guess if it didn't like the first x squared, it's not going to like this guy either. So let's just see what happens. 12.9. What is 15? 155 divided by 12 is 12.9. Okay, so that is correct. Ooh.